Okay, this is Lab 2, Charge Tapes Revisited by Hiley. So the purpose of this lab was to create charge samples using tapes and to approximate the excess charge on these tapes. But in this lab, we're going to be doing the same thing, except instead of assuming that each tape is a point charge, we're going to assume that um, the charge will be evenly distributed throughout the tape. And some of the physical principles we're going to use are Coulomb's law for point charges and Newton's second law for the forces on both tapes acting on each other. So here are our measurements for the tapes, and here are the results. As you can see, the gravitational force was very similar to electric force. And the experiment model that we're going to be focusing on is the one in the top right, where we have one tape below the other, and the polarization of these tapes is going to create it's going to make the top tape go up. So onto the glow script. The computational model that we had got us a charge of 2.6 to negative 8 from Coulomb's law, and then the electric field function here was copied over from lab 0. And then the line charge function, it creates a line of n uniform point charges with a given total charge. And on the bottom here are the positions of the top tape and the bottom tape, where the top tape was above the bottom tape by our distance, and each tape had a length of 20 centimeters. And I decided to divide each tape into 50 parts, which just represent like the infinitely small sections of tape. Okay, and then we figured out the change in the change in charge in the top tape and the change in charge in the bottom tape. We calculated the electric field and electric force by just plugging in values, and then we multiplied the electric force by our electric scale to get the arrow. And finally, we created the arrows. So the arrow electric force going up was the scale times the electric force, while the arrow going down represented the force of gravity, which was just negative weight of the tape. But then we printed out the results, which is right here. So the arrow going up represents the electric force on the top tape, while the yellow arrow going down represents the gravitational force. And as you can see, they're very similar, but there's a few sources of error. And each of the green arrows represents like an infinitely small piece of tape. So some assumptions that we used for lab 2 is that we ignored air resistance on a moving object. We did this so it was easier to calculate forces, and we can neglect a lot of forces by air. And then we also assumed that each U-tape was evenly distributed throughout the whole length, which is what changed in this lab compared to last lab, because lab 1 was assuming that each tape was a point charge, while now we're assuming that each tape is evenly distributed. And then some what if questions and why questions. So what if we use a point charge model? This would result in a higher charge estimate because the electric force is stronger when it's concentrated onto one point, while when we're comparing it with a line charge model, we're gonna get a lower charge estimate because the force is spread out. It's gonna be weaker because like the radius to the observation points is gonna be longer. And some of the why questions, why these estimates are different, is because the point charge model assumes a concentrated charge onto one point, while a line charge considers like evenly distributed charge. And this is going to result in weaker forces and lower charge estimates, like we said before. And which estimate is closer to the actual value? The line charge model is going to be closer to actual value because we're not assuming that a tape is going to be concentrated all into one point, and it's going to be a more accurate estimate.